Okay, so today I wanted to record a bit of an actual project I've been working on. Um, and I had intended this to be the first live stream, but apparently you need 24 hours for YouTube to verify your account before you can start live streaming. So instead of that, I have to settle for a recording. But maybe that's okay because yeah, I don't know how this is really gonna go. So maybe it's better that I still, start slow, baby steps. All right. Yeah. So I think. Well, I just kind of want to jump into the project. I'm not gonna spend. Uh, I was thinking. I was debating about whether I should talk about like the project, give an introduction to it. But I think it'd be better to kind of have its own like separate introduction video, uh, which who knows when I'll ever get to that. But I think uh, parts of the project will be revealed as I'm discussing it. Um, but I think the first thing I just wanted to do was like go through this code that I haven't looked at in a while. I haven't really worked on this project in a while. And yeah, just kind of I don't really have too much of a plan for today other than just like kind of just like doing what I would have done if I wasn't recording um, for like 40 minutes or something, and yeah, like talk through the process, talk through whatever I'm doing. Yeah, so I have all this data, right? This station data that's all downloaded. What the station data is like if I open up any of these files, right? It shows me it's this JSON file with a huge dictionary, I think dictionary of station information, right? So you see at the top level you have data and then stations, and what this is containing is each of these entries is a snapshot of the status of a station at some point in time. Like you can see the name of the file is when that um, data was downloaded. And so each station, right, has a whole bunch of different fields, right, a bunch of information that you can look at, right, number of e-bikes available, which I think it's kind of hilarious that's here because there are no e-bikes at all in the Blue Bike system, but there are in other bike sharing systems made by this company. And then there's like simple stuff, whether the station is operating or not, the number of docks available, right, which is the number of like free docks available. Yeah, all sorts of stuff. I'm not sure what this means. Is returning. I don't know what that means. Number of bikes available, pretty obvious, Yeah, some other funny things I kind of noticed. There's like a legacy ID, and then there's a station ID, and they're usually the same thing. Um, what else? Is renting is installed? Not really sure what that means. I guess is renting probably means like is that I don't know. Is it that means how many bikes are like currently on the road that have left the station? I'm not sure what that means. Um, yeah, last reported is this is like a timestamp as well for when the last time the station sent out information, I guess, to the main server. I mean, and yeah, a lot of useful information. This one, for example, is interesting. I mean, this station is just totally out of service, right? So it's no bikes available, no docks available. It's still on this list though because it's just part of the legacy. And yeah, so from this data, right? I have this data saved. Uh, when this code was running, so I have a script that um, grabs this data from the internet, right? I can actually show you where that data is. Let's see, is it this one? That's station information. I think it might be in this Yeah, I think so. Yeah, here it is. In this, at this URL, right, you can see this. This is the JSON file that stores the current status of all the stations in the Blue Bikes network, active or deactivated. And this file, this JSON file, refreshes like pretty regularly, like every 5 seconds or something. But the thing is that it doesn't save past copies of it, so there's no database, as far as I can tell, of past station data. And so that's the reason why I had to write this script, which I'm not going to go through, but this script is kind of like it's not a web crawler, but I guess it crawls this specific URL and just saves this JSON data on a timer, and I have that timer set for 5 minutes, right? So that's what all this data is this JSON saved every 5 minutes. And I started the script back in the end of November last year, and it's just been running continuously, more or less continuously, up to today. So yeah, what I was gonna do today was to revisit this script first. First was to revisit this script, because this script was what I was using to do some like really simple, not even data processing, just loading this information, all these JSON files, and then plotting the station capacity over time for a specific station that I was looking at. Right, so maybe I'll actually just start by running the script, because it might be interesting to see what it does. So I do Python simple bb data load. Okay, and so now the script's gonna literally load all of these files, all of these JSON files, one by one, and then it's gonna plot the station data for this one station. And I actually messed up. I need to kill this. Oh shoot, can I kill this? Let me do this instead. I'm just going to close this window. I'm running Anaconda, by the way, which is really, really nice for, anyone who's doing data science stuff. Okay. Yeah, I remember what the issue was now. I'm actually loading it from my Google Drive. This code was actually, sorry. Loading all those JSON files from my Google Drive, which is really slow because it has to actually download all that stuff off the cloud. So I temporarily transferred all the stuff to my desktop, but I forgot to actually update the path. So let's update that. Yeah, I have two base paths here, one for my laptop and one for my work computer, which is basically like a little bit of like, I don't know, what would you call it, inter-machine operability? But yeah, I need to update the one for my laptop, which was this. So let's do that. And one thing that I'm sure there's a better way of doing this, but I'm just like picking the easiest, most dumb solution, which is like Python strings, recognize, is this forward slash or backslash? I don't know. This direction of slash plus a letter is like a special character, but it's also the slash that Windows uses, the Windows OS uses for pathing. So I have to like double slash to escape the slash key. But anyways, whatever. Yeah, let's try this now. Let's see what happens. Yeah, and this was like, I really wish, this is the reason why I wanted to do this live, is because, I don't know, maybe someone watching would be able to tell me a smarter way of for example, copy pasting these paths and not needing to like escape every backslash. Although that's not, like, it's a pretty trivial problem. I'm sure I could just Google that. But yeah, let's try this. So simple bb data load .py, and It'll load files and it'll tell me every time 100 files have been loaded. And I'm hoping that because they're on my desktop that they will load quicker. Okay, yeah, it's going. Yeah, this is gonna take a while. Maybe I don't even need to load all of these files. Maybe I should have just like loaded a subset of them, because this is gonna take way too long. Well, I guess while it's loading, I could kind of explain what this project was about. So yeah, I in Boston here in the city, there's a bike share program called the Blue Bikes program, and it's this network of bicycle sharing docks where you can basically rent out a bike and then take it from one dock to another dock and on some time limit. But it's like a publicly available bike renting service, right? Yeah, fully automated. Check out bikes through the app, or if you can also get like a physical key. You could pay for an annual pass, and it's like a really great way of getting around because it's super affordable. It's super convenient. You can take one-way trips, right? Unlike if you had your own bike, you wouldn't be able to do that. You'd risk leaving your bike somewhere to get stolen. If you tried to do a one-way trip, you don't have to care about like maintenance, all that, and it's really nice. And one of the really cool things about it too is that they publish all this like free station or system information online, and so I was looking at this information and trying to figure out if I could do something with it, do some like data sciencey stuff with it. And kind of what my motivation was, right, is that the area where I live is a very in-demand area for bikes, but there's definitely not enough supply to meet the demand. And so a lot of bike docks are always either empty in the morning or too full at night. And so you can't check them out in the morning to go to work, and you can't return them at night when you're coming back from work. And so I kind of wanted to do some statistics and see if I could like prove, that the certain areas are being undersupplied or underserviced than other areas. Right. So that was kind of the very quick summary. But yeah, so you could see this script loaded all of these data points, right? Each data point is one snapshot of the station capacity, right? And here I'm defining capacity as the ratio of the number of bikes that are docked to the total number of docks, or the total number of bikes that the station can hold. And that's happening over time, right? And this is a really long time scale. There's a lot of data, so there's not really a clear way to interpret this. Maybe we can zoom in and look at some of this data, right? Yeah, zooming in is useful because we can see, right, this station, like the capacity oscillates a lot over time, right? I would say, although, yeah, so the x-axis is not showing me more data points, which is unfortunate, but this is probably, I would assume, right, one rise and one fall is 1 day's worth of data, because the rise usually happens on a weekday during rush hour, the fall is during rush hour in the morning when everyone's trying to go to work, and then the climb is at night when everyone's trying to return to the docks because they're going home. And you could see that this station, right, it spends a lot of time down here at the 0 mark, right, where there are just no docks, no bikes available whatsoever, and that's not a good thing. And this variation is also not a good thing, right? And basically, if you see this kind of like, it's saturating at 0, it's saturating near 100%, that means that the dock is not keeping up with demand. Yeah. So what I wanted to do, right, I wanted to do some like statistical analysis on this really basic stuff, like looking at, um, the average capacity over time, the average capacity for a certain window of time, you know, um, the variance I think would be really interesting to look at, because I mean if you looked at the average, right, the average value, can I zoom back out? Yeah, so I'm not that familiar with, oh my god, how do I zoom out? Let's look it up. With Matplotlib. Zoom out. Why can't I zoom? How to zoom out? Yeah, and the, okay. This is not telling me what I want. Well, anyways. Rescale? Are you serious? Can't even zoom out. Ugh, it's terrible. Alright, so yeah, I wanted to look at the variance because, I'm going to guess the average capacity is probably somewhere in 50%, but the variance will really tell you, like, oh, is the capacity of this dock changing too much, right? And then looking at stuff like the slope, I don't know, well, all sorts of things could be looked at with this data, which is like really cool. I think it's really fascinating to be able to have this data. Yeah, so I wanted to actually do this because it gets, very slow to have to load all of this data at once. So I think today, the first thing I wanted to try was to just figure out how to save this data to a single file, like all this data to a single data file that I can then load back in with NumPy, which is what I'm using to do the analysis, right? Yeah, yeah, probably the best thing to do would have been to do this in a Jupyter notebook where I could yeah, script things and run things incrementally, but I don't have that set up, so we're kind of running it through the script, the command window. So I'm going to look this up actually. NumPy save data. NumPy.save. That seems pretty straightforward. Straightforward enough. NumPy.save. Save an array to a binary file in NumPy format. Okay, yeah, that's exactly what I'm looking for. File or file name to which the data is saved. Okay. Array data to be saved. Allow pickle? I have no idea what pickle is, but okay. Default's true. I'm probably not going to deal with the optional options, but look at some example usage real quick. Cool. And then there's the load function. Alright, I want to give this a try. So yeah, I think maybe I should start a new script actually, because this script was kind of doing this JSON file loading. So I'm going to hit save as. I'm just going to make a copy of it, start from this copy. And I'm just saving these codes for now to my Google Drive. Ideally, this stuff would be versioned with some versioning tool like Git, and then also hosted somewhere publicly. I mean, I want this to be like a kind of like a open source, not open source, but just, openly available type of thing. But yeah, right now it's just, there's not that much code, and I'm just messing around with stuff, so it's in my Google Drive. Yeah, so I'm gonna call this, what am I trying to do? Load JSON, save to NumPy. Let's just call it that for now. Not very informative, but whatever. I like to try to make file names as informative as possible. uh, but also that's also what the header is for. Header? I don't know. Comments. Okay, so this is what I want to do. I want to load all JSON information and save all information to a NumPy data file for quicker loading. Right, great. All right, so now let's go through the code and see what needs to change. So I've got my dependencies, right? Nothing important to go through there. And then the main part of the script. So the first thing this script does is it loads station data from this JSON file. And this is just one of many JSON files that the Blue Bikes service provides. Right, so if we open up a browser and check out this JSON file, this one's just storing static information about the stations. I think. Should be, yeah. Yeah, this is kind of interesting because, so they have this file, right, that stores station information, including like the name of the station, right, a lot of metadata. I don't know what rental methods, okay, rental methods. It's got latitude and longitude information, so you can find this on a map, and that's part of what I want to do with this data, which is do some like GIS, geographic. What does GIS stand for? GIS, Geographic Information System mapping, which is making maps of stuff. It's a fancy word for saying I'm going to make maps of stuff. So it's cool that they have this information. Then I can easily put this stuff on a map, put these stations on a map. Yeah, but this JSON file just contains like static metadata information. So I load that first so I can get the station info, right? The actual station information is in this file. This where'd it go? Right, not in the script. In this script, this JSON file that gets refreshed all the time. Yeah, it's kind of funny. That file doesn't even contain like the station names, so you kind of have to like cross-reference, which I think is what I might be doing here. So I get station info, which is json.loads, url.read.decode, whatever. This station info just loads that station info JSON file as a single dictionary, right? And then I'm looking at a specific station here, and I just manually pulled the index of that station in the array, in the station info array. If I was smart, right, a smarter way would be to figure out how to cross-reference between like the name of the station and the entry in the station info, but that's fine. And then what I care about here is grabbing the capacity, right? And also the info, but I'm not sure if I use that anywhere. And then after that, right, we go to loading all the JSON files. So here I'm selecting a path for where all the JSON files are located, and then loading, well, checking if that path exists, and then if it does, then I load each file, or actually, what is this? Only files, only files, oh my god. Okay, this is grabbing all of the file names of the JSON files in that path and discarding any file names or directory names, anything that's not a JSON file doesn't get kept. Okay, then we initialize these NumPy arrays, capacity versus time, and timestamp. So it looks like, and I've forgotten about this, so it looks like I load all this information, but I only keep two pieces of information, which is capacity versus time, and then the time. So It's kind of wasteful, but also this is why I want to save this data to NumPy files right now, because then in the future, right, I would only be loading the information that I care about. And then we start loading the data, and I literally just go through each file one at a time, open the file, load the data in that file, and then grab the information that I wanted, right, which is the number of docks that are available at that time, the bytes that are available. Then that just lets me calculate the capacity versus time. Oh, I guess I don't even use ndocs. And then I get the timestamp as well. And then I have this counter that just tells me how many files I've loaded, so I can keep track of the loop. I'm not just staring at like a blank screen while stuff's loading. And then very simply I just plot capacity over time with like the most basic format of plotting that I could with matplotlib. And it looks like, and I also, these timestamps are loaded in what's called epoch time. And that's like a time format that's not really like a human readable time format. So I just use a simple function, some date time function to convert that timestamp in epoch time, right, to a human readable string format. And then that becomes the X label, the labels for the X-axis. Great, okay. Well, that was the original script, which is what, was doing all this. I think I will keep all of this, right? There's nothing here that I need to like erase. Even the plotting is useful because I could still, it'll show me that like, oh, the data is being loaded properly, and I could still view it. All I need to do now is just add add a bit that saves data to NumPy binary. Yeah, so this is, I was looking at this. This is interesting that it kind of looks like you can only save one variable at a time. Is that true? Save several arrays into an MPZ archive. Maybe I should look at this. Yeah, maybe this is better because I have two arrays that I want to save, right? I have the capacity versus time array, and then I also have the timestamps array. I want to save both of these. So let's look at this. Save several arrays into a single file in uncompressed MPZ format. Great. Okay. X equals X, Y equals Y. If arrays are specified as positional arguments, their names will be array 0, array 1. Interesting. So this syntax actually names the arrays. X equals X means in the file you would name that X array X, I suppose. Parameters, stringer file. Okay, right. So the first argument is just the name of the file to save. 2, and then args is arrays to save. Alright, simple enough. Yeah, I like to very simply just like copy paste the code. Okay. Or not. Maybe I can copy paste this. Yeah. What do I use for NumPy as my object name? Yeah, or whatever it's called. So numpy.saves. Let's say save file name equals what? Well, I had all this data here, so I might as well just like save it to here, or maybe one level above. Save it to the desktop. Yeah, this is funny. I'm just gonna give it a jump name for now. Data. I'm gonna give it a timestamp, 220212, 2243. All right. Is there like a certain extension I should be using? Uncompressed.mpz. I'm gonna assume it like already saved in MPZ format. Let's try it. Let's see what happens if we do this. Okay. So save file name, and then we want timestamps as the first variable to save, and capacity versus time as the second one. And that's it, I think. Yeah. Okay, well the annoying thing is I'm gonna have to rerun this script, I think, right? There's no way for me to like just execute this right now. Is there? No, I can't type anything in there. Alright, so let me close out of matplotlib. Oops. Okay. Yep. So let's just run the script. It's gonna take a bit to load. You know, okay. What I'll actually do to test that this was working is I'll just work on a subset of this data. So just take freaking eons to load. Oh no, why did I do that? Okay, that's fine. I just cut this data, so it saved all this data to the clipboard temp. I don't need to save all this data to the clipboard. I'll just take all of this and just move it. And hopefully this doesn't take forever to move. My computer's kind of slow, showing its age. Oh, is it moving? Or is it too many files to move? I ran into this problem earlier. It was like too many files to move. Okay, better, let me just do this. I'll just grab the files that I want. There. Okay, and then I will update this path. Oh shit, it's moving. Let me cancel, don't do that. Okay. Alright, let's give this a shot. Shoot. Python s load JSON save to npy. .py. So I'll check how much time I have left. 7 minutes. Cool. Wait, that's funny. How it's the same capacity over this time frame. Oh, that's right. Yeah, I mean this is like an hour's worth of data. All right. Is it done? Oh, right, it is done. Yeah, one of these things I need to figure out how to get Python to return control without needing me to manually close the plot. It's kind of an annoying thing about matplotlib. Let's see if that file saved. I'm looking at the wrong place, aren't I? I am. Shit, I'm still looking at the wrong place. Here we go. Oh, right, there it is. It's right there. Cool. Okay. Okay. Yeah, I want to know what's in this file. I've never made one of these before. Yeah, let's. So to look at what's in this file, let's just look in the Python. I don't know what this is called. Command environment. Shell sounds right. Let's look at how to load stuff. Load. Oh wait, I just saw it right there. Okay. Load arrays or pickled objects from NPY or NPZ. Okay. Great. I feel like this should be really, really straightforward to use. Like you just load a file and yeah, save it to some structure. With load as data, I've never understood what the with block means actually, but I see this all the time when it comes to loading loading things and saving things. Oh god, no, please. Alright. Well, this should be pretty straightforward to do. All we need to do is load this file. And the syntax seems really simple. Well, first I have to import NumPy, which I've forgotten how to do. Import NumPy. Just do that. Okay, and then NumPy.load. Let's save this to a variable. I'll just call it x. NumPy.load, and then the file, which is gonna need escaping. Yeah, I need to find a better way to do this. And the data, the file name. Dot npz. Okay, let's see if that worked. Well, it loaded as an npz file object. Interesting. Okay, well now how do I like investigate what's in this file? Result, array, tuple, dict, etc. For npz files, the return instance of npz file class must be closed to avoid leaking file descriptors. Interesting. If the file is an npz file, then a dictionary-like object will return, returning file name, array, key value pairs. Ah, okay. So I guess we have to treat it like a dictionary. So we should be able to get keys from it, right? Is this how it works? No? Working or getting keys of npz file. File completely? Let's look at this. How to read and show MP file. You can do list, d.keys. Yeah, okay, let's try that. List x.keys. Did it work? Ah, very nice, very nice. And then you should just be able to access like x timestamps. X capacity versus time. Okay, and that matches with the plot that showed up earlier. Very cool. Okay. Well, this actually is nice because now that I have the script that'll let me save this data, right? I could overwrite, or I can rewrite this code to not even need to load all this stuff from this from all these JSON files. I can just load the data from this npz file. npz. Yep. So let's do that and try running this code again. See what happens. Load from npz file. Okay. And I'm gonna actually do it this way, where I separate the file path from the file name. Usually makes things a bit easier to keep track of. Alright, file name equals this dot mpz. Great. Okay, and yeah, we'll just load the data. Data equals here's np.load, np.load file path plus file name, and we'll just add another escape, and then there's no real reason for me to, okay, actually, yeah, alright, I'll go ahead and do this. Timestamps. I'll extract the data. Timestamps. And fastest time equals data. And this is nice, very easy for me to know what the variable names are because I saved them exactly as they were loaded. Cool. Alright, let's try the script, see if it works. Quit, parentheses. Alright, let's try it out. Python simple pb data load. Boom. Awesome. Great. Okay. So oh, that's it. That's my timer's going off, so I'm calling it for tonight. But yeah, I guess recap, was able to save some data that I had already downloaded to a NumPy data format file to make it much faster for me to load the data next time and do some analysis. Yep, so that's it. Thanks for watching, whoever's watching. Yep, see you.